We all think we know what a filter is, right? I mean, you've probably got a bunch of them in your house right now. But what if I told you that our whole idea of a filter being just a simple strainer, well, that's just the very, very tip of the iceberg. The real story is so much more complex and, honestly, a whole lot more brilliant. Just think about that for a second. A coffee filter, that just blocks coffee grounds. A colander in your sink, it just stops pasta. Simple. But how in the world do you use that same idea to provide clean, safe water for millions of people? The short answer is, you don't. The process that actually makes that happen is something else entirely. All right, let's get into this. The first thing you have to wrap your head around is that industrial-scale filtration isn't just a bigger version of what's in your kitchen. No way. It's a fundamentally different process that relies on a whole team of, well, invisible forces. So check this out. Simple straining. The one we all know, that's just one player on a team of at least 6 different forces all working at once. Yeah, you've got the obvious ones like sedimentation, where heavy stuff just kind of settles out on its own. And then there's interception, which is basically when a particle just happens to bump into the filter and stick. But this is where it gets really wild. You have forces like diffusion and adsorption, where atomic-level physics literally pull impurities right out of the water. It's less like a net and way more like a full-on scientific ambush. Okay, so now that we kind of get the how, let's take a look at the what. What does one of these advanced filters actually look like on the inside? Here we go. This is your classic gravity filter. You can see the dirty water, what engineers call the influent. It comes in right at the top. From there, it slowly works its way down through all those layers of filter media. That's the sand and gravel. Down at the bottom, you've got this complex underdrain system that collects the now clean water, while the control panel over on the side manages the whole show. It's less of a kitchen gadget and way more of a finely tuned machine. And that really brings us to the most important point of all this. The steel tank, the pipes, that's just the housing. The real magic, the absolute workhorse of this entire process is the stuff inside it. It's the filter media. That's where all the science really happens. And the details here matter a lot. Just look at the shape of the media particles themselves. If you use sharp, angular grains, they create bigger gaps between them, which isn't so great for catching the really tiny impurities. But smoother, more rounded media? Well, that can pack together much more tightly, creating this intricate, winding path that's way better at trapping those super fine particles. But here's the thing. Using just one type of media, like fine sand, created a huge problem. I mean, it worked great for a little while, but the top layer would get clogged with gunk almost immediately, bringing the whole operation to a screeching halt. So, engineers came up with an incredibly clever solution. They decided to layer different types of media together. It's called a mixed media filter. At the very top, you have a coarse but really lightweight material, like anthracite, that catches all the big stuff. As the water sinks deeper, it passes through finer sand, and then finally, super fine but very dense garnet at the bottom. This coarse to fine design uses the entire depth of the filter to do its job, which makes it dramatically more efficient and lets it run for much, much longer. Now, you might be thinking, wait a minute, doesn't all that stuff just mix together into a useless jumble when you clean it? And the answer is no, thanks to some beautiful physics. The secret is density. The lightweight anthracite naturally wants to stay on top, the heavier sand settles into the middle, and that super dense garnet always sinks right to the bottom. So after every single cleaning cycle, the layers perfectly reset themselves. It's just brilliant. So, with that core principle of layered media in mind, let's see how engineers have adopted this basic design for all sorts of different jobs. It's created a whole family of specialized filters. The two main workhorses you'll see are gravity and pressure filters. On the left, that's the gravity filter we've been looking at. It's open to the air and just uses the weight of the water to push it through. But on the right, you've got a pressure filter, which is a completely sealed tank. Now, why seal it? Well, that's crucial when you're working with, say, hot water, or you need to keep the water pressure high for an industrial process. If you opened it up to the air, you'd lose all that heat and pressure, and that's just a huge waste of energy. And check this out, some designs get really, really creative. The upflow filter completely flips the whole concept on its head. Water is actually pushed in from the bottom and flows up. This way, the largest particles get removed first by the coarsest media at the bottom, and the water gets cleaner and cleaner as it rises to the top. And for maximum, non-stop efficiency, you have the continuous cleaning filter. Inside this thing, dirty sand is constantly being pulled from the bottom, lifted all the way to the top by an airlift pump, washed clean, and then dropped right back onto the filter bed. It literally never has to stop working to be cleaned. It's the ultimate multitasker. Which brings us to a really critical question for all those other filters. Eventually, they all get clogged with the junk they've removed. So what do you do then? You definitely don't throw away tons and tons of expensive media. No, you do something much smarter. You basically hit a giant reset button. This process is called backwashing, and this illustrates it perfectly. You just reverse the flow. Clean water is forced up from the bottom so powerfully that it actually expands the whole filter bed, making it act like a fluid. It lifts all that trapped gunk right out of the media and flushes it all the way into a waistline. And this isn't just some nice little feature. It is absolutely essential. Backwashing is what gets rid of all those solids that I've built up. It's what prevents the formation of these dense clumps called mud balls that can totally ruin a filter for good. And most importantly, it completely restores the filter's capacity, all without having to replace a single grain of sand. So here's the big takeaway. A large-scale filter isn't a static trap that you just use and throw away. It's a dynamic, self-renewing, and highly engineered system that's designed to run for years and years of reliable service. But the engineering doesn't stop there. What if you need to remove incredibly tiny particles, like microscopic oil droplets or bacteria? For that, there's a technique called precoat filtration. Instead of a deep bed of sand, imagine you paint a very thin, absolutely perfect filter layer onto a screen. This layer, it's often made of a powdery substance called diatomaceous earth. It does its job for one cycle, and then it's completely washed away. Then, a brand new, perfectly clean layer is applied for the next batch. It is literally like using a fresh filter every single time. It's filtration on a whole other level. You know, it really makes you think. We've taken something as basic as pouring water through sand and turned it into this sophisticated, self-cleaning, multi-stage science. It really leads to a final question. If there's this much hidden engineering going on inside a simple filter, what other simple things that we rely on every single day are hiding their own incredible story of complexity?